Hi, welcome back. In the last video, we understood what is a reflexive relation, correct? We also gave an introduction to what is an equivalence relation. We defined equivalence relation as a relation which satisfies all the three conditions: reflexive, transitive, and symmetric. A relation which is reflexive, transitive, and symmetric is said to be an equivalence relation. That's what we learned. Now, we also understood what a reflexive relation is. Today, we're going to understand what is a transitive and a symmetric relation with an example. Let us consider a set A as 1, 2, 3, and 4. Now, I'm going to be defining a relationship R or a relation R, A, B, order pairs A, B, such that A minus B, the modulus of it, is equal to 1. I'm picking up very simple examples for relationships because I want you to understand the concept behind it. Okay, now, again, we need to understand or realize that A cross A is going to have 16 elements. Because the first set has 4, the second set has 4, so A cross A is going to have 4 into 4, 16 elements. Now, the ordered pairs belonging to this particular relationship R are going to be 1, 2, 2, 1, 2, 3, 3, 2, 3, 4, and 4, 3. Because the difference between these elements are 1, and hence I pick up these elements or these ordered pairs as a part of the relationship R. What do I see here? I see that 1 is related to 2 under this relationship R because 1 minus 2 is minus 1, and the modulus of it is a 1. 2 is related to 1 under the same relationship R because 2 minus 1 is equal to 1, and the modulus of it is also equal to 1. And hence, here I see 2 is related to 1, and also 2 is related to 1, and also 1 is related to 2. Likewise, 2 is related to 3, and 3 is related to 2. So, in this fashion, if A is related to B under the relationship R, that implies that B is also related to A. A relationship which satisfies this condition is said to be a symmetric relation. Now let's go ahead and understand a transitive relation. Again, I'm going to be picking up the same example. Here, I'm going to define a relationship R, A, B, such that the first element is lesser than the second element. Okay? Great. Now, let's understand the order pairs belonging to this particular relationship. 1, 2, 1, 3, 1, 4. I cannot include 1, 1 because 1 becomes equal to B. 2, 3, 2, 4, 2, 4, 3, 4, and nothing more. Correct? Let's see here. 1 is related to 2, 2 is related to 3, and 1 is related to 3 here. 2 is related to 3, 3 is related to 4, 2 is related to 4. So this now becomes a transitive relation. A relationship in which A is related to B and B is related to C implies A to be related to C. This type of a relation, or the relation which satisfies this condition, is said to be a transitive relation. Overall, if a relation satisfies all the three conditions, that particular relationship will be called as an equivalence relation. I would like to now show you a clip from the NCERT textbook. And here is a clip. This explains to us what is a reflexive, symmetric, and transitive. And here we can understand what is a reflexive relation. So that put together defines my equivalence relation. Now we're going to look at a very small example to understand equivalence relation in a better way. Let us consider this example taken from the textbook, the NCERT textbook. Here, he's talking about the triangles, a set of triangles in a plane where R is a relation in T given by this particular relation. Now let's understand what's a plane. To understand what's a plane, we need to understand what surface is. A surface is something that we can touch. There are two types of surfaces. One is a flat surface and the other is a curved surface. A flat surface is your computer screen, and a flat surface is the table. Your book is a flat surface. The pen that you are holding is not a flat surface. It is a curved surface. It has a curved surface. The ball has a curved surface. Drinking glass has a curved surface. A flat surface is called as a plane. Now, let's consider this as a surface. In this surface, or the plane, I can have a lot of lines which are parallel, perpendicular, intersecting. I can have dots or the points, innumerable points and innumerable lines that I can have. Along with that, I can have any two-dimensional figures like the triangle, the quadrilaterals, the pentagons, the octagons, and so on and so forth. Among these, I am picking up the triangles alone. Different types of triangles. I can have a right angle triangle, I can have an obtuse angle triangle, I can have an acute angle triangle, or different types. So that's the set I'm gonna take. Let's take that set as T is set of triangles in a plane. Set of triangles in a plane. Okay. Now, the relationship that has been defined to us is this. I'm going to pick up two triangles which are connected to each other such that the first triangle is congruent to the second triangle. Now, that's a relationship that's been defined to me. Okay. Now, I'm going to check if it is reflexive, transitive, and symmetric. Let's see. This is the symbol used to define congruency. It simply means that two triangles are going to be congruent to each other. Let's say triangle 1 and triangle 2. They're going to be congruent to each other if all the angles are equal and sides are also equal. Okay. So basically, I'm talking about two triangles to be exactly the same. Okay. Might be they are flipped around, but they are exactly the same. That's congruency for me. Now, if I'm trying to apply this particular concept here, any triangle is exactly equal to itself, isn't it? It's going to be the same replica of itself, which means the triangle is related to itself under the relationship R. Let triangle 1 belong to the particular set T. We know that triangle 1 is always congruent to triangle 1. Implies triangle 1, triangle 1 belongs to R, isn't it? Therefore, R is reflexive. All the triangles in this particular set T are congruent to itself, which is true, and so it is reflexive. Now let's understand symmetry. For symmetry, okay, for symmetry, we need two triangles, so let's pick up two triangles. Let triangle 1, triangle 2 belong to the set T. Whenever we are proving symmetry, we're going to put a condition. That's the first condition. We say triangle 1, triangle 2 belongs to R. We are putting this condition that it's belonging to R. Now, keeping this condition true, I'm going to go ahead and prove that the second condition is true. What does this imply? Triangle 1, triangle 2 is belonging to R. Simply means that triangle 1 is related to triangle 2 under the relationship R. And what is the relationship R? Congruency. If the first triangle is congruent to the second, or if the first triangle is equal to the second, then the second is equal to the first. Simply means that x is equal to y implies y is equal to x. So, triangle 2 is congruent to triangle 1, which implies that triangle 2, triangle 1 belongs to R. So I've now gone ahead and proved that keeping the condition triangle 1, triangle 2 is true, triangle 2, triangle 1 is also true. Therefore, the relationship R is symmetric. Now, let's move on and prove transitivity. For proving transitivity, I'm going to consider three triangles. Let triangle 1, triangle 2, triangle 3 belong to the set T. And here, for proving transitivity, I'm going to put two conditions. The first condition is, let triangle 1, triangle 2 belong to R. And the second condition is, triangle 2, triangle 3 belong to R. So here, I'm putting a condition that triangle 1 is connected to triangle 2 under the relationship R. Triangle 2 is connected to triangle 3 under the relationship R, which simply means that implies triangle 1 is congruent to triangle 2 and triangle 2 is congruent to triangle 3. Well, we already know that if A is equal to B and B is equal to C, simply implies that A is equal to C, isn't it? It's the same thing in algebra being duplicated in geometry. So this implies that triangle 1 is related to triangle 3 under the same relationship R, which means they are congruent. And that implies that triangle 1, triangle 3 belongs to R. Therefore, R is transitive. So, simply means that these two conditions being true, the third condition, which is triangle 1, triangle 3, is also true. With that, we have gone ahead and proved transitivity. So, what do I see here? I see that the relationship R is reflexive, symmetric, and transitive. And hence, this relationship will be called as a equivalence relation. We will look at one more example in the next video.